shock's coming. Holy smoking Toledos. Man.
Holy smoking Toledos. My favorite part of that whole video. So you can imagine, that's a pretty crazy video to get on, to actually be there when a volcano erupts. Now, we didn't see any lava with that, but that was a pretty intense video, no? I wouldn't like to be, on that mountain, whatever. We're going to talk more about that, but I thought that was a great intro to what we're talking about, right? Volcanoes. So this is the second video or second note sheet for our units on earthquakes and volcanoes. So we first talked about earthquakes, now we're going to talk about volcanoes, right? And I know you know what a volcano is, but we're just putting a definition to it, right? A vent in the earth where hot magma and gases are expelled, right? Deep within our mantle, it's churning this magma, and as that magma makes it to the surface, it turns into lava. Okay, the only difference between magma and lava, magma's underground, lava's on top of the ground, or when it gets to the surface, it just changes name from magma to lava. Okay, now where does most volcano activity occur? Well, at the plate boundaries, so anywhere where we have plate boundaries, but specifically, where do you think? Where do we have most of our volcanoes around our world? That's right, the Ring of Fire. All right, let's dive into a little bit more. So, what are some effects, right? If you were standing on that mountain when it erupted, you might not be here anymore, right? Because either the shock wave might have killed you, knocked you on your booty, or maybe you got hit with some pyroclastic ash or dust or debris that was ejected at massive speeds, right? Maybe you got gobbled up in the lava. Maybe you got gobbled up in the ash. Lots of people can die from volcanic eruptions, right? Another thing is it changes the local climate. So when this volcano erupts, it spews massive amounts of dust and ash into the air. Well, that dust and ash, along with gases that it releases, like methane or sulfuric acid, CO2, it changes the local climate right around that mountain or right around that volcano. When it erupts, it changes the gas, the atmosphere around it, so it can change the climate right around it. Usually, when there's a volcanic eruption, a volcano erupts, there's a lot of rain that's associated with that right around the mountain. Okay, so it can change local climates. There's an increase in CO2 gas in the atmosphere. It can cause a tsunami, right? It's kind of not easily relatable, but when a volcano erupts, typically there's an earthquake associated with that. So if that earthquake happened, in the bottom of the ocean that caused this volcano to erupt, that earthquake could have caused a tsunami. So just because it's a volcano eruption doesn't mean that there can't be a tsunami. There absolutely can be a tsunami. Okay? And we can see destruction of building, gas explosions, water pipes break, flood, just like we saw with earthquakes, right? We could see that here in volcano eruptions as well. Now, what's interesting is that after this volcano erupts and all the dust and ash settles to the ground, we have new, very fertile, lots of carbon is in this ash and dust. So when that carbon gets mixed in with the dirt, very fertile soil, right? So plants and animal life regrow and flourish very quickly after a volcano erupts. If you look at Mount St. Helens, when it erupted, it killed tens of thousands of acreage of beautiful tall growth forest trees and foliage. Well, you look at it now, 30 or 40 years later, it has all grown back. Now, we don't have these 100-year-old trees, but the plant life is flourishing in this fertile soil from the volcanic explosion. New oceanic crust, right? So if this volcano erupts at the bottom of the ocean, like Hawaiian Islands have been formed, it's new oceanic crust, and then it can erupt again and erupt again and eventually build an island that peaks out of the water. But if it starts at the bottom of the ocean, that's just new oceanic crust that's being formed. And then the last thing is poor air quality and visibility. Why do you think it's not very easily, you can't see very easily? That's right, because of the ash, right? The dust and ash that encompasses the volcanic eruption. I'll show you a video of these mountain climbers that get caught in a volcanic eruption dust storm or ash cloud. And then obviously if there's a bunch of particles in the atmosphere and you're breathing them in, that makes for very poor air quality, right? That's going to get into your lungs and it could cause significant damage, sometimes death, because of those ash clouds. Okay? Now, we've got 3 types of volcanoes that we're going to investigate. Number 1 is called a shield volcano. And it's called a shield volcano because it looks like a shield if you lay it down on its side. Right? So a shield volcano is called a shield volcano because it's got very low sloped sides. Right? And so it looks kind of like a shield that's laid on its side. Now here would be the mouth of the volcano, and when it erupts, the lava just runs off the sides and makes a very not steep volcano at all, but a very broad volcano. Okay? The Hawaiian Islands are an example of a shield volcano. This volcano has been erupting on the Hawaiian Islands for since 1982 or 83, something like that. So for over 30 years, it has been erupting, and it's a very runny. It's a very runny lava, not a huge explosion when this volcano erupts. It's a very broad base with gently sloping sides, quiet eruptions of runny lava. Okay, and I think over here you're going to see a picture of that running lava that forms a domed type structure. There's very little gas buildup, and because there's little gas buildup, that's why we're not going to have huge eruptions. It's when that gas gets built up is when we have those huge eruptions, like the beginning of our video. That is not a shield volcano, the video at the beginning of this video. That is a different type of volcano. Okay? And then we have the next type is called a cinder cone. Okay? Now a cinder cone is relatively young, right? These cinder cones can be created very quickly over weeks or sometimes even months. These cinder cones can be created, right? So it's very steep sloped in the shape of a cone and can be up to 40 degrees in slope, and it rarely is more than a few hundred meters high, and it is formed from extremely explosive eruptions. Okay? Now, what's interesting with cinder cones is that there may not be any lava associated with the cinder cone. It might just be ash and dust that gets spewed out of the ground along with gas, and that ash and dust creates these cones, these cinder cones. Okay? And that's where we see very steep very steep cone like this. Okay? And it's a young volcano. Not a very old volcano. Now, the next one can be some of the oldest volcanoes on our planet, right? And that's the last one we're talking about, which is called composite volcanoes. Mount St. Helens was an example of a composite volcano, right? Made of alternating layers of lava flow and made from explosive eruptions. So we see things like this image here, a very large mountain, right? Snow-peaked mountains. When there's snow on them, you know that they're really tall mountains, right? So very tall, snow-peaked mountains that are alternating between lava flow and gas or dust and debris, and so you have this alternating layers, right? Alternating layers of lava flow. And these can go hundreds of years between eruptions, right? Mount St. Helens was thought 300 years ago was the last time that Mount St. Helens had erupted. And we're thinking that it might be another 300 years before it erupts again. Okay? So those are the three types of volcanoes that we're going to talk about, right? Shield, which is a very flat, not steep sloped sides. Running lava forms it. Composite is called what's called a pyroclastic flow. Very thick lava forms these volcanoes because it's very thick and sticky. So when it erupts, it sticks to the side and builds the mountain up rather than running down like a shield volcano does. It erupts and sticks to the side, right? Like a booger out a window. Okay, maybe not that analogy, but think of it like, you know, water running down a hill, which is the runny lava, versus like molasses or very thick syrup running down the hill. The syrup is going to solidify very quickly, or the molasses is not going to flow as easily as the water running down a slope, right? So that's kind of the difference. Composite can be very, very tall and extremely old volcanoes. And then the last one is cinder volcanoes, right? And the video that I showed you in this area, that happened over the course of a few months. This volcano was formed, this cinder volcano, okay? Now, the last thing that we need to talk about is what's called a caldera, okay? These are large circular depressions that form when magma chambers below the volcano partially empty and then the ground sinks as a result. So here's an active volcanic chamber, right? A magma chamber that's creating a volcano. Now, for whatever reason, that magma chamber is being emptied or slowing down. It's not getting the heat source. And so the ground starts to depress or push back down. And over time, this magma chamber is still stopping its heat source. And then so we see the depression of the top of the volcano, right? This would be at the very tippy top of the volcano, right? We're talking about right here, right? So over time, you would eventually see, right, a depression at the top of the volcano. Now, who's to say that this magma chamber can't, again, thrive or produce heat? And so now we have this big cap of solid rock that has kind of capped it off, and then we have this growing heat and pressure, heat and pressure, heat and pressure, and then, you know, sometime later, we could have a very pyroclastic eruption, or a very, very powerful eruption, okay? Now, how do I measure volcanoes? Well, we measure them on what's called the Volcanic Explosivity Index, or the VEI. To calculate this, scientists use three things to calculate the size or the measurement of a volcano, right? In a volcano eruption. The amount of material released. So how much material, dust, ash, debris is blown into the atmosphere or around the volcano. The height of the eruption column, right? So in the video in the beginning, right, you see this initial eruption, and then all that dust and gas goes upwards. Well, they measure how high does that make it into the atmosphere, right? That gives them a calculation. And then the duration or the length of the eruption. How long did it erupt? How long did lava flow out of it? Or how long did debris blow out of it? And so on. So those three things together give them an index or a number, so to speak, of the eruption, right? How big was that eruption, okay? We're going to talk more about volcanoes, and we're going to look at some videos in class, but that just kind of gives you an overview, right? Three types of volcanoes. We have, and then, know the difference between those three, right? Shield, cinder, and composite. Know the difference. Why do we see shield volcanoes have a very low slope? Why do composites have a very steep slope? And so on. So this is the end of your second video. I hope that you have learned something, and we're going to talk. I expect some questions when we come back on this video. Okay? All right. Peace out. 6th hour. You're my homies. Peace out.
So I hope